Hello, we're back again. We're going to be solving quadratic equations with square roots. This is just a way to figure out what x is to make this equation true. And there's one more thing with it. It also tells us how many roots or how many zeros or how many x-intercepts are in a quadratic equation. But this is more of solving as opposed to just graphing. But I can show you what it looks like by graphing. With that said, let's go ahead and get started. I must preface something though before solving any of these. These have an x squared and a number. There's no 3x or 5x or anywhere in these three equations. And that's very important because if there's a 3x or a 5x or some kind of x in this equation mixed with the x squared and a number, you can't solve it using this method. It just has to be an x squared and a number. That's it. That's the only way you can do it. There's a story I use, but I'm probably not going to do it now. So I got 2x squared equals 8. What I want to do is get x squared by itself. So in order to do that, it's 2 times x squared equals 8. Now what's funny is if you're trying to solve for x, you do the reverse order of operations. That's how it goes. Like if you want to simplify an expression, use the order of operations. But if you ever want to get x by itself, use the reverse order of operations, which I think is kind of cool. So 2 times x squared, I'm going to divide by 2 first. Now people say, can't get rid of the square first? No. The square is actually more into, well, it's more closely related to the x than the 2 is. So 2 divided by 2 cancels or becomes a 1. X squared equals 8 divided by 2 is 4. Now the story I use is something like about a Metroid. Metroid was a game back in 1985 by Nintendo, and I tell my student, one of my students to come up here, and they really like this activity. Well, it's not an activity; it's just a presentation. And I say this Metroid wants to, harm this X. Now you've got to be sleek about how you destroy this Metroid so it doesn't harm this X. Now if you walk away and ignore it, the X is in danger, peril. And if you try to attack it, it's like a bee, all of a sudden it's going to get scared and sting you. And that doesn't work either. So you got to be sleek about how you get rid of this square. And the only way to get rid of a square is by doing something, and I tell my students that, this is a dangerous move, don't go outside in the classroom and do it. Because you could hurt somebody, but if you ever got to defend yourself against the equation with a square or anything, you can do it. And I call it the square root move. See, and then that actually is something that causes a stir of laughter, and they really love it because I also have a piece of paper. I have a student holding it up above their head, and I show them how to do it. But since I'm not your teacher in class, I can't do it. But yeah, you got to be sleek and then do that. So embarrassing. So you take the square root, and see how it just like destroys the 2? Goes right through. But what you do on one side, you got to do on the other. Now what I tell my students is this. It's so dangerous of a move that one year I forgot to tell students the disclaimer beforehand that you shouldn't be doing this outside the classroom. So there were a lot of injured students that year as my class excitedly went out of the room doing this to random people in the hallway. And needless to say, there were a lot of people in the nurse's office that day. Yeah. So I say that it's good and it's bad. It's good because it can help you destroy squares. But it's bad because you can hurt innocent people. So whenever you take the square root of something, you've got to account for the good and the bad. The positive and the negative. And the square root of 4 is 2. Bam. So x equals plus or minus 2. If you want to write it out a different way, you would write x equals 2, x equals negative 2. Either way you write it is fine. And basically what that means is if I were to graph this, I know that the graph is going to go up because the number in front of x squared is positive. And I know it's going to hit at negative 2 and at positive 2. And it's going to go up. And that's just a very quick way to graph something using the square root method. For this one, I've got m squared minus 9 equals negative 9. What I want to do is get everything without an x on one side and everything with an x on the other. Actually, everything with an x squared on the other side. There should be no x term. Add 9 to both sides. M squared equals 0. You got to use that. And I say square root, and all of a sudden you have students when they're doing their homework, when you give them some time in class, all of a sudden you hear a course of square root. And I'm thinking to myself, what did I do here? So anyways, take the square root, you damage that square, it's gone. But what you do on one side, you do on the other. M equals, it's plus or minus, but there is no such thing as positive 0 or negative 0. It's just 0. So your answer is 0. And if you want to look at this type of a graph, really quickly, without making a table or etc., well, it's positive, m squared, there's no negative in front of the m squared, and it hits at 0. So the graph looks something like that. Not exactly, but something like that. And the last one, you want to get everything without a variable on one side, everything with a variable squared on the other. B squared equals negative 4. B equals, you can't take the square root of a negative number unless we're talking about imaginary numbers. And even though I had a lesson that talked a little bit about imaginary numbers, when it comes to graphing quadratic functions, you have to graph real solutions, not imaginary solutions. So there are no real solutions for this problem, which is kind of odd in its own right to talk about imaginary and real. Now, what that graph looks like is something like this. Now, I don't know exactly what it looks like. I know that the number in front of the b squared is positive 1, so I know it's going to go up, and it's never going to hit the x-axis, so it could look something like this. See, it's never going to hit that axis. So that's a brief introduction. I wanted to continue actually solving square root equations, a little bit more difficult, mind you, but not really incorporated with the graphing. Excuse me. That said, I hope that was moderately helpful. Have a good day for now. Goodbye.